everyone! I'm Kendy Guiaya. I'll be your guide through an exciting part of fluid mechanics, measuring the flow using flowmeters and Venturi tube. Have you ever wondered how engineering know how fast water flow through pipes and how doctors monitors oxygen flow? Now, let's dive in and find out. First, what do you mean by flow? In physics, the flow rate tells us how much fluid passes through a point of a given amount of time. It's usually measured in a cubic meter per second or liters per second. To measure the flow, we use the flow meter. These are devices that help us to measure how fast or how much fluid is moving. There are many types, but one of the simplest is most interesting is the Venturi tube.
A Venturi tube has a special shape. It's wide and the both ends and narrow in the middle. As fluid flows through it, the pressure and the special change depending on the width. According to the Bernoulli's principles, when the fluid speeds up in the narrow part, its pressure goes down. This pressure difference can be used to calculate the flow rate. Venturi tube and flow meters are used anywhere. In water supply system to monitor the flow in pipes. In medical equipment like oxygen flow regulators. In cars, for controlling how much fuels goes into the engine. Even in industrial plants where chemicals are moving through pipes. These tools help ensure safety and save money and improve efficiency. So now, let's try a sample problem using a Venturi tube. Problem: water flows through a horizontal Venturi. The wide section has a diameter of 10 cm and the narrow section has a 5 cm. The pressure difference is 2,500 Pascal. So, what is the flow rate in cubic meter per second? We're given a pipe with a wider section and narrow section. The diameter of the wider section is 0.10 meter and the diameter of the narrow section is 0.5 meter. The pressure of difference between two sections is 2,500 Pascal and the density of water is 1,000 kg per cubic meter. We need to find the flow rate in the cubic meter per second. First, we calculate the cross-sectional area of both sections using formula for the area of a circle. Next, we use the continuity equations which state that the mass of flow rate is constant throughout the pipe. This gives us A1V2 is equals to A2V2, where the V represented velocity. Now, we apply Bernoulli's equations using describe the conservations of energy in a fluid. Since the pipe is horizontal, we can simply the equation to this. To solve for the flow rate, we need to combine these two equations. Let's solve these continuity equations for V2. V2 is equals to A2 V1. We substitute this into a Bernoulli's equation. After some algebraic manipulation, we arrive at an equations for B1. Now, we substitute the known value to calculate B1. Now, we substitute the known value to calculate V1. Now, finally, we use the continuity equation and the calculate V1 to find the flow rate. Therefore, the flow rate of water through the pipe is approximately 0.0092 cubic meter per second. This analysis demonstrates that the practical applications of Bernoulli's equation and the continuity equation is solving fluid dynamics problem.
Measuring flow is super important in real life. From clean water to clean air, the Venturi tube is a clever and a simple way to do this using basic physics. This activity helps me understand how pressure and speed related in flowing fluids and how engineering uses this principle in real-world situations. My advice? Don't be afraid of the equation. They're just a tool to help us to see how world works behind the scene. And that's all. Thank you for watching, and I hope you learned something cool today.